myself, and these are my group members. This is Palak Patel, Farhan Karimula, and Neil Patel. And today we're going to talk about the project we have done so far for the 3 months, and it's the extraction of fulvic acid from Shalijit using alkali soluble acid precipitation method. So today I will give us a brief introduction on what is Shalijit and what is fulvic acid and what is humic acid. So basically, Shalijit is a tarry, grease-like substance. It is found in the Himalayan regions by the breakdown of plant and animal substances for over a decade of years. So Shalijit has its own health benefits, which makes it a good thing for So in Shalijit, it consists of 2 forms of humic acid substances, and one of it is the fulvic acid component, and the next is the humic acid component. Here, the main objective of our project is the extraction of fulvic acid from Shalijit. So here, we are extracting fulvic acid from Shalijit at different pH ranges, especially the lowest pH ranges. And for that, and we are studying how much we extracted, the effect of pH on the extraction of fulvic acid, and why pH has importance in the extraction of fulvic acid. And now here comes the main question: why we chose fulvic acid instead of humic acid? It's mainly because of the chelating property of fulvic acid. In fulvic acid, it has the ability to bond with metal ions. So we extracted fulvic acid from Shalijit to learn more about its chelating ability. That's why we conducted this experiment in lower pH ranges, that's below pH 3, that's pH 1, 2 and 3. And it also has one more property, like for the patients who doesn't have the ability to consume Shalijit as a whole, especially the patients who have lower blood iron content level, they don't have the ability to consume Shalijit as a whole. So if we extract fulvic acid and we give fulvic acid component of Shalijit to the patients, they can consume fulvic acid component of Shalijit with the same therapeutic effects. So that's the main reason why we extracted fulvic acid from Shalijit. Now I'll pass on to Farhan to say more about the procedures that we have followed.
Hello everyone. So I'm going to talk about the workflow and what we have done in the lab and about the challenges we face. So we got our sample from Amazon, and which is a edible resin. So what we did first was we dissolved 1 gram of our sample in water, and it was completely dissolved. So even after that, we tried to filter it, and we removed the excess solvent by simple heating. So after that, we tried to extract the fulvic acid. So for that, we used the organic solvent. In our case, we used the methanol. So we tried to use cold methanol and hot methanol to understand the effects. So we use methanol. After that, we dissolved the residue we got after the extraction using 0.1 NaOH. We used around 5 ml of NaOH. So after that, this alkaline solution, we acidified it using 0.1 normal HCl. So it's done for the humic acid precipitation, but unfortunately in our case we didn't get any precipitate. So we tried to do the centrifugation. So we did it at 3500 RPM for about 4 or 5 minutes. So even after that, we didn't get any precipitate. So we followed an alternative procedure. In this procedure, we simply took 1 gram of our sample and we added to 2 ml of NaOH. After that, we vacuum filtered. Then we acidified the sample to 1, 2 and 3 pH, which is our desired pH, using 1 normal HCl. After that, we dried our sample using an oven for about 2 days at 50 degrees Celsius. So we got a crystallized sample. So we did FTR analysis with our crystallized sample, and after that we did titration just to confirm the presence of fulvic acid. Then we did duplicates and triplicates just to confirm our presence. Now I'm going to talk about the difficulties that we faced during this project. The sample that we got from is from Amazon, which contains less Shilajit content, and it contains an Ayurvedic blend. So we considered it as an impurity. So we're supposed to get a rock Shilajit sample. Unfortunately, it's not available online. So we think we didn't get any precipitate due to our sample. So we purchased another sample and we tried the same procedure with it. And the other challenge that we faced is we got only 50 gram of sample. So we done our procedure according to that. So we get our residue at very little quantity. So during titration process, our sample was brown in color. So we couldn't use the methyl orange indicator because the color was not visible. So we used the pH meter instead of that. So these are the readings. So I'm gonna ask Parag to describe about the statistical data.
So for statistical data, we perform one-way ANOVA and Tukey-Parway comparison method to compare three different pH with our duplicates and triplicates. And here we got P value is 0.593, that is greater than our significance level alpha 0.05. So we don't have any more like statistical difference between all of our pH. And for Tukey-Parway comparison method, we perform with three different pH again, and we compare all different pH with their duplicates and triplicates, and we can see here all comes in the same group, so there is no any significant difference between all the pH over here. And moving forward for FTIR analysis, we perform FTIR with the filter paper and sample, and also with only filter paper, just filter paper, and in between the range of 650 to 4000 centimeter inverse. And here we can see carboxylic acid group, benzene rings, ether, C double bond O, like that ketone, OH, and carbohydrates. So during FTIR, we got OH functional group in between 3400 to 3200 centimeter inverse, that for like C double bond C double OH or phenolic group. And then from 2920 to 1850 we got C single peak for C single bond H. And for aldehyde and ketone, we got peak over here at 1720, and for benzene ring we got peak here for 1660 to 1600, and here we got some peaks in fingerprint region. And as per our references that we took, we supposed to get peaks over in fingerprint region too. That's for like 1033 for ether, and 1220 to 1230 we got pick for C single bond O. And I would like to call Neville for further.
Hello guys, we got group samples. As for mentioned, first we get a Shalijit blend, which is already a processed one, so we didn't get a fulvic acid content. Then Margaret purchased a new Shalijit, which is a pure Shalijit. So we get fulvic acid content, but we get little trace amount. So to conclude, presence of functional groups such as OS, carboxylic acid, benzene ring, we confirm by the data. So we get a fulvic acid. Another, we get a different peak of a fulvic acid content and also oxygen containing group. Third one is critical analysis revealed there is no difference in the yield percentage at pH 1, 2 and 3. We also tried in triplicates. We got a same result by comparing all these data. So further step, future students can investigate wider pH ranges. Although we tried many pH ranges, but future students can use a different pH more than us. Another thing is they can use different temperature ranges and duration time for more yield content. Third is employ NMR spectroscopy for detailed structure insight into fulvic acid. Evaluate fulvic acids with diverse metal ions for potential industrial application. Encourage collaboration to enrich fulvic acid research. So thank you.
So you said at the beginning that you were looking into this for medicinal purposes to help with blood work. How does based on your conclusion, do you think the data supports or does not support the use of fulvic acid for that purpose?
Yes, our data will support that in the way of like at which pH we can get fulvic acid. So as per our project, we can get fulvic acid from any pH 1, 2, 3 because there was no difference. Like if we could have done on pH 1, 3 or pH 6, 7, then we will get any difference. But yes, we can get fulvic acid from those pH.
Of those three options, which do you think is the most efficient based on the data you collected?
I think 3 of them are same.
They're all about the
We
same.
got almost similar results from all of it, like even in titration for pigs and everything.